Miss Heather here. Hope you're all doing well. For this week's class, we're going to discuss rainbows and do a couple really fun experiments. But first, let's check out our biodome that we made last week and see if it's working. If you can see in here, the grass seeds have begun to sprout. The water and moisture is trapped inside. I put my bottle in a sunny spot by the window, and after only 1 week, we have a nice amount of sprouts inside. Very cool, right? I hope yours turned out well. Our first experiment will explore the dyes found in candy and how they dissolve in different test liquids. We will be using Skittles, vinegar, seltzer, or a clear soda like Sprite or 7-Up, cold water, and hot water. Before we get started, we need to understand what the word dissolve means. When something dissolves, it means it's attracted to the liquid it's added to. It mixes in and becomes a solution. Sometimes you can mix something with a liquid and it doesn't dissolve. It just becomes a mixture, and the two ingredients float around, mix together, but do not become a solution. For example, think of salt water versus sand and water. Salt is attracted to water, and when it's mixed in, it will turn into a liquid and dissolve in water. It looks like the salt disappears, but really it is dissolving and turning into a liquid, salt water. What happens when you mix sand with water? Does the sand turn into a liquid and become a solution of sand water? No, it just sinks to the bottom and you have wet sand or a mixture of sand and water, but not a new solution. Salt is attracted to water, sand is not. During our experiments today, we're going to test different liquids will affect the dye in our candy. Which liquids will dissolve the dye fast? Which liquids will take a little bit longer? Dyes in candies are great to use because we can easily see whether the colors are moving through the liquid or not. And candy science is a fun way to experiment. For this experiment, we're going to use Skittles. If you don't have those, you could also use M&Ms, or maybe Jolly Ranchers would work. You could even do the experiment with a couple different types of candy to see which dyes dissolve the fastest, depending on the candy. I have 4 small plastic plates that I've put the Skittles around the outside edge. I'm going to test hot water, cold water, vinegar, and seltzer in each dish, pouring very slowly into the center till the plate is completely covered. This one will be the cold water. Next, hot water. And you can see the reaction is already starting to happen. The hot water, which is this plate here in the front, is working really fast. Now it's time to try seltzer. Seems so far that the hot water is the fastest one to dissolve the dye. The cold water has a beautiful rainbow. Oh, and it looks like the seltzer is starting to get the dye dissolved too. Be careful not to bump the table or shake because it's really cool to see the pattern and see how the dyes go off in the rainbow. Finally, the last one, vinegar. So as you can tell, each of our test liquids are able to dissolve the Skittles dye. The hot water, which was this one on the bottom left, was the fastest. The cold water has done a really good job. And I love the seltzer with the little bubbles inside. Finally, the vinegar has made a beautiful, easy to see pattern of color. I hope you guys enjoyed doing this experiment. Hi boys and girls, for our next experiment, we're going to be making a walking water rainbow. Here's the supplies you'll need. 6 small plastic cups or glasses. Food coloring, red, yellow, and blue. Water, and paper towel. I have the Select-A-Size smaller ones. You can use any paper towel you want. What you'll need to do is fold it long ways in thirds. And you want to make sure it fits in the cups without sticking up too high like that. You want it down a little bit lower. So a pair of scissors to trim off the end. Give it a nice press to fold it. I even press the feet and test it out before we get started with our experiment. Yeah, that looks pretty good. Okay. So I have 1 cup of water and I'm going to dye that red. The more food coloring you add, the brighter the effect will be. I have an empty cup in the middle. Next cup, I'll make yellow. Another empty cup. This cup, I'm going to fill up with water almost all the way up to the top. We'll make that blue. And then 1 last empty cup for the end. Let's get started. So we take our folded paper towels and we're going to put one end in the red and one end in the empty cup and continue along, linking all 6 cups together. Now I'm going to just form them into a small circle, and we can watch the water begin to walk up the paper towel and into the next cup and see the colors mix together. Forgot to connect the red here with the blue in here. So as you can see, some of the colored water is already starting to travel up the paper towels. This is called capillary action. That's the ability of a liquid to flow upward against gravity in a narrow space. It's the same thing that helps water climb from a plant's roots to the leaves in the treetops. Paper towels and all paper products are made from fibers found in plants called cellulose. In this demonstration, the water flowed upwards through the tiny gaps between the cellulose fibers. The gaps in the towel acted like capillary tubes. The water is able to defy gravity as it travels upward due to the attractive forces between the water and the cellulose fibers. I'm going to just carefully stretch this out a bit so we can see the color happening a little bit faster. And you'll notice that my cups of water, the yellow, the red, and the blue, look like they're decreasing a little. And the empty cup that has some yellow and some red in it, that will turn to orange. You can always add a little more water to your cups of primary color, since the paper towels are absorbing a lot of the water and we want to see the full rainbow occurring. This experiment is fun to watch to see the colors expand over time. You can spread your cups out a little bit and see if that helps the liquid travel from cup to cup. And afterwards, you can even carefully take out the paper towel, let them air dry, and use them to make a craft. So guys, about 10 minutes has passed since I began the experiment, and as you can see, we have a beautiful rainbow forming. There is now water all the way up, just about in the cup of green that was empty when we began. We have purple forming too, and almost a full cup of orange. And we have created a beautiful walking rainbow. Well, boys and girls, I hope you had a good time today with our Skittles candy rainbow and our walking water experiment. Have a great week.